Howdy, statisticians. I know you've missed me, so I'm back. So today we're going to look at non-standard normal distributions, and that simply means that the center of my bell is no longer 0 for the mean, mew, nor is it 1 for the standard deviation. But I'll know that I get to draw a bell still by ding, 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 ding. Ooh, I see roughly normal. Normal distribution is good enough for me, even though it says roughly normal. So the minute I see that, I go, oh, mean, there's my mu. And standard deviation, there's my sigma. So I'm going to draw my bell. Aren't you so happy about drawing these bells? And I'm going to label those. So you can see down here, I've got the mean and the standard deviation. And then I move on to my question, and of course it's involving 334, so I put 334 in an appropriate position on the bell, and since it's less than, I'm shading to the left. So now, in order for me to figure this out, remember I can't compare apples and oranges, and I can't look anything up in the chart until I have a z-score. So over here to the side, I have to remember, how was it I find z-scores again? Oh, that's right, I do x minus mu over standard deviation. So in this case, I'm going to be doing 334 minus 336 over 3, which gives me negative 0.67. I'm going to round it to tenths because my table uses tenths, and then I'm going to go look it up in the table. So I've got to go to the negatives and look up, why does that 7 not want to look like a 7? Close enough. So I got to go look it up in the table. So go look up negative 0.67, and when I look it up, I get an area of 0.2514. If I love percents, I can write it as 25.14%. Remember, area and probability and percents all mean exactly the same thing. Okay, moving on to question 2. So again, I've drawn my bell, got the mu and standard deviation in the center, and this time I want between 332 and 337, so I've labeled them. But that means I'm going to have to find 2 z-scores because I need to look up 2 areas, and then of course I'll subtract them, which is what we've been doing. So I'm writing out my z-score twice. Yes, you have to show all this work. Okay, goody. You get to cry and whine and complain at home. Oops. This is 3. I don't know why I wrote sigma. That should be a 3. And so these equal negative 1.33 on the left and 0.33 on the right. Makes sense. I should have a positive z-score to the right. And so now I need to go look up both of those areas in the table. So stop and do that. So I get each of those numbers. But remember, the table is reading to the left. So to the left here is the 0.0918. And all the way to the left here is the 0.6293. And I want to get rid of this stuff so that I only have the stuff in between them. So I'll have to subtract. So I get 0.5375 for the area, or the probability, or the percent. It did ask me the percentage, so I suppose I can write it in percent form. And there's my final answer. So again, on this next one, I have drawn my bell, labeled the center. This time I'm looking longer than 338 days, so I put that in. And now I've got to z-score it. So 338 minus mu over sigma. And rounding to the nearest tenth, so I can go look it up in the table, gives me 0.7486, but remember, that's all the stuff that's to the left, so I'm going to have to subtract it from 1. So I get 0.2514, or 25.4%.